So this is a supplementary lesson to deriving the 5 kinematics equations. I gave you a set of questions that involve using the Irwin textbook physics questions on constant acceleration. This is one of the questions in there, and I'm going to do it as an example of using the problem-solving method and applying the 5 kinematics equations. So I'm going to do question number 54. It's the first one here, and then I'll do a very quick give you a very quick idea of what you have to do for the second one. So question 54, if we're going to follow the 7-step method, the first thing we have to do is to find the target. So we're going to say, what is the answer? What are we going to find out? Well, the question is asking, how long does it take? That's a time. So our final answer is going to look like a time. T equals something, and time is measured in seconds. We can also identify significant digits. We're given a distance of 553 meters, a speed or an acceleration is 9.8 meters per second squared. That's 2 significant digits, so our final answer is going to have 2 significant digits. Next step, that's step 1. Step 2 is to draw a picture, make a diagram, or understand the concept. Put it in words if you don't like drawing pictures. So we're dropping something from the CN tower, which means we're going to start at a certain point. It's going to fall at a constant acceleration. It's going to end at a certain point. Now we can have a constant acceleration. So 9.8 meters per second squared. And at this point, we can really actually put in step 3 because we're starting to put in given information. Step 3 involves putting in given information. We know the distance. 553 meters per second. I'll enlarge this and make it a little easier. So a distance of 553 meters per second. And there's another piece of information. Now there's 2 different things you can have. You can have explicit information, so information that's just given and you don't have to think about it. And then you have information that's kind of inferred. And one of the things that's inferred here is that an initial speed of 0 is what we're doing. So, given information, we have an acceleration, we have a distance, sorry, that's not meters per second, that's meters, and we have a v1, and we're trying to get a time. So there's steps 2 and 3. We've identified what we have to do and what we know. Step 4, formulas that could possibly be involved. Well, we have 4 of the 5 kinematics variables. We're missing v2, which means this is going to be in equation 3. Equation 3 is the distance is equal to the initial speed times the time plus 1/2 acceleration times squared. Really all we have to do, because we're being asked, we're being asked to solve for time, so we have to rearrange this equation for time. Now something nice we can observe is if v1 equals 0, but that cancels this entire term. So we're actually left, now we're kind of starting into algebra here, so I'll call this step 5. Distance equals 1/2 a t squared. So we know the acceleration, we know the distance, we need the time. So we can rearrange this equation. To rearrange the equation, we have to multiply by 2 and divide. So we've got 2d and divide by a, and that gives us time squared. So time is going to be equal to the square root of 2d over a. Plug the numbers in, so that's number 5. Step 6 is plugging in the numbers to get the answer. Time equals the square root of 2 times 553, all divided by 9.8. I'm going to pause, and I'm going to calculate it. You should do the exact same thing. So, my final answer is 10.623, and I won't take it any further than that, seconds. And we have to worry about significant digits for the final answer. That's step 7. And we're required to do 2, so we've got to truncate it here. The 6 is going to round it up, which means we have a final time of 11 seconds. Now, that's question 54, and we were lucky in that question 54 canceled out or made that v1 term disappear, so we didn't have to play with the quadratic formula. Question 55, you're going to need the quadratic formula. So I'm going to erase this, and we're going to try it again, but I'm going to do it a little faster this time. So question 55, circle this, so if you're coming in the middle, you see. We're still looking for a time. Still going to have two significant digits, but this time we're given a v1 and a distance, and of course, we're still going to have the same acceleration. Same equations, or same picture, except now we have an initial speed. So we have an acceleration, an initial speed, and a distance. That's this is going to be steps 2 and 3. This is step 1. Step 4, formulas. Distance equals v1t plus 1/2 a t squared. Nothing's going to cancel for us, so we have to rearrange. Solving this for t, we need to do the quadratic formula, and the quadratic formula requires this to be in standard formation, which is 1/2 at squared plus v1t minus d equals 0. In this equation, we represent this, which is a what's the word I'm looking for? Coefficient. We're going to call that a. Notice that I'm including the operators here, plus and minus. That's going to be coefficient b, and this is going to be coefficient c. Quadratic formula is x equals negative b, I'm using capital letters to differentiate the acceleration, plus or minus the square root of b squared minus 4ac all over 2a. So we're going to replace those bits of information. I'm going to do this. I'm going to bring this all the way over to the other side where there's a little bit of room. So I'm going to say time is equal to b, which is v1 squared, negative v1 squared, plus or minus the square root of v1 squared minus 4 times 1/2 acceleration times negative distance, that's your c, all over 2 times a, which is 1/2 acceleration. We can do a little simplification here. Negative v1 squared plus or minus the square root v1 squared. The 4 cancels out the half and becomes a 2, and the two negatives cancel, so we get plus 2ad all over a, because the 2 and the half cancel. And now we have all those bits of information, so you can plug them in. Again, I'm going to pause, and you should too. Okay, so my calculation, following that method, which is wrong, by the way, comes out to 8.0 seconds. Now the actual answer is 10.125 seconds. My challenge to you at this point is to figure out what I did wrong. It's a very simple little mistake, but it's a good challenge to figure things out. So I'm going to take the right answer, plug in my significant digits, and to write 10 to two significant digits, I want to put a decimal at the end. The other way I could do that is 1.0 times 10 to the 1 seconds. Either one works. Okay. Good luck. Feel free to ask questions in class.